So I'm going to do this a couple of ways. First way is I'm going to open up Excel. And this is not, it didn't ask you to do this. I'm going to do this just because I think it's a good way to look at this. Let's see, these pills, 57.3. Okay, and again, if you want to follow me on your own version of Excel, 0.4. This is 57.2, 57.5, 57.4, 57.0, 57.1, and finally, oh, did I miss one? 57.3, 57.4, 57.2, 57.5, 57.4, up 57.3 I missed. Got 57, so this is going to be 57.3. I'll just put this one down here. And I'll get rid of this 0. We don't need that anymore. Okay, everybody agree with me that that's right? Going to find my mean, my standard deviation, and then my standard error. So my mean is equal to the average of all these values. My standard deviation is equal to standard deviation of all these values. My standard error is going to be equal to my standard deviation divided by the square root of the sample size, which in this case, the sample size is 8, which is equal to that number. Okay, so now I'm going to calculate a 95% confidence interval. Okay, so my 95% confidence interval is going to be equal to, well, first thing I'm going to do is I'm going to calculate my margin of error. My margin of error is going to be equal to the t-score that I need to use. Let me see if I can't find my t-score down here without going back to the page back there. Nope. Here we go. Oh, no, that's wrong. I'm going to have to sneak back here and take a look. Let me reopen this file. Okay, so in this case, our sample size is 8. So our degrees of freedom is 1 minus our sample size is 7. I'm going to go across, it's still working with a 95% confidence interval. I'm going to go across here, and my t-score that I need to use for 7 degrees of freedom is 2.365. Okay, let me get back to Excel. Excel, 2.365. 2.365 is t times my standard error. So my margin of error is 0.13, 0.14 roughly. So our 95% confidence interval is going to be equal to my mean minus my margin of error, and it's going to be equal to our mean plus our margin of error. Okay, so our 95% confidence interval, based on this sample of 8 pills, we're 95% certain that the true mean for this entire population of pills is 57.14 to 57.41. Everybody agree with that? Did I make a mistake in there again? Row 6 is, well, actually, I put the 57.3 down here because I missed it. Right? Am I right? Somebody tell me if I'm right, that I gave that right, that column of numbers is correct. Right? I just skipped that number, so I put it at the end. Wake up out there. Do I got the right column of numbers there? Bill? You agree? Yes? Okay, good. Thanks. You see what happened there? I skipped 57.3. I realized it, so I just moved it to the end. Okay, so thank you. All right. I got to check every once in a while, make sure, if not, like there's not a lot of response out there and stuff like that. I get worried that I'm talking to myself, although I do that, but not intentionally. So our 95% confident, we're 95% sure that the true mean for the pills that this machine is producing is between 57.13 and 57.4. Let's look at the problem. The manufacturer says it produces 57.6. Well, there's a problem here. We're 95% sure it's not 57.6. We think that it's between 57.1 and 57.4, not 57.6. So we're 95% sure that this manufacturer is wrong. His machine is not producing a pill that weighs an average of 57.6 milligrams. His machine is producing pills that have less of the nutrient, and that's less of the nutrient or whatever supplement that's intended to be given. Okay, so how do we know we're 95% sure he's wrong? We know we're 95% sure that he's wrong because we have a range for what we think the 95% interval is for this particular sample and population of pills. The 95% the confidence interval based on a sample of 8 for this population we think is between these two numbers. So we're 95% sure that that's where the mean is. So if somebody says the mean is outside of that, we're 95% sure that they're wrong. Now, if the mean is between these two, let's say it's 57. The manufacturer claims that the average pill weight is 57.3. Well, we can't say that he's wrong because it could be 57.3 and we still satisfy our 95% confidence. It could be 57.14 and we couldn't say that he's wrong, even though it's at the low end, because we only know that we're 95% sure what the range for the mean is. Okay, so there's a big difference. Now, one of the things that was asked of me earlier was, well, how do I know I add the margin of error to this mean that we calculated based on the standard on the sample? Why don't I add it instead to what the manufacturer claims? He says it's 57.6 and my margin of error is 0.13. Why don't I do equals 57.6 plus this margin of error and 57.6 minus this margin of error? What's going to happen is that the range, the margin of error, the range that you wind up with is going to be the same width. It's going to be margin of error below, margin of error above that width. It's still going to be different than the mean that we calculated based on our actual sample by the same amount. This is still going to be either inside that this confidence interval or not. So we're going to get the same result in terms of whether or not it's within or outside the confidence interval. So it really doesn't matter in terms of what our result is, whether or not we would argue that the manufacturer's claims are wrong. The conclusion wouldn't change. However, really, even though we're testing the idea that this is 57.6, right? Really, all we really know about this population based on our own judgment is what we know from the sample that we took. So in essence, we really should be working with this as our point estimate, not what the manufacturer claims, and with this as our margin of error based on what we sampled. It kind of makes a little bit more sense to do that, even though it may not change the result very much. Okay, so I think probably in most cases, that's the way you're probably going to work. Okay, so now let's go look up a little further. It's going to get, when you look at the way we phrase hypotheses, our null and alternative hypothesis, it may get a little funky in terms of like suggesting that maybe you should have used 57.6. I could see how you might consider it that way. But for a confidence interval, it's pretty clear that that's probably what we should use. Now, we're going to get on to talking about hypotheses at this point. Okay, so now, okay, now we can use SPSS to do the same thing.